Bismillahirrahmanirrahim. Dear students, I am Ahmed Mumtaz Mustasan, your teacher for CSC 141 Introduction to Computer Programming. Students, today we will discuss and study the applications of arrays. Arrays is a data structure and it has got some very interesting application associated with this particular structure. There are certain operations which can be performed on any structure, since arrays are also considered as a structure. So there are operations that we can perform on arrays. These operations are traversing, searching and sorting. Traversing कहते हैं to access each element of the structure exactly once. Searching to find out the location of an element in the structure by a given value or a key. Key means the value of any particular element stored into the structure, stored into an array. Or finally, the next operation that can be performed is the sorting. Sorting कहते हैं to arrange the records in order. Order क्या? Ascending order or descending orders. There are few more operations that can be performed on any structure. These are called insertion and deletion. But since arrays is a data structure which is by nature a static data structure. क्या मतलब हुआ static का? Static means constant. The size remains the same throughout the execution of the program. So you cannot increase the size of the data structure, you cannot decrease the size of the data structure. Therefore, insertion and deletion performing an array is illogical. But since this is an operation, so in some books you might find insertion in arrays and deletion in arrays, but that is something else and I'll teach you in some advanced courses. So, application of arrays. Although we have touched this topic before, I have taught you searching, I have taught you sorting and linear search and the bubble sort also. But today I will show you some examples, and for that purpose I have picked up these examples from the website, and thanks to Prentice Hall, for where I have picked up the applications. A very good demonstration with some animation. So I'll be using these slides to demonstrate you and to explain you how these applications work and perform. Okay, so let's start with the searching. As I said, searching means to find out the location of a particular element. Location of a particular element by a given value, which is called a key. So in the linear search, which is basically a sequential search where we search each element one after the other, until we find our desired element which we are searching for. Okay, so we compare the element of an array with the key value and start from the first element, then we keep on moving to the next element. This particular linear search is very useful for small size data structures. But small size array, this is okay. But if you have a very long array, okay, if you have a long sized array, or if your key is usually it is performed on the unsorted data structure, unsorted array. So it becomes inefficient if the size of the array is very large and if the key is not present. What does it mean? If the key is present, you can expect to find it in the first half sometime or in the second half sometime. So on average you may say that first plus last divided by 2, so on average it is half the size of the array that you need to search. But if it is not present, and most of the keys, if they are not present in the structure, then what you are required to do? Obviously you are required to go through the complete the complete size of the structure. क्या मतलब हुआ इसका? To access each and every element of the array until you reach to the last one. क्यों last तक जाना पड़ेगा? Because the key is not present. So if the key is not present and if the size is very large, then this type of searching is inefficient. So what can we do? I'll give you another example or another technique after this particular technique. So this is the code for the linear search function. As I said, I have picked up from the website, so you can find out the icons here also, and this is the material I have picked up for you from the Printess Hall website. So this function compares key to every element of an array until location is found or until the end of array is reached. So what will happen if you find the key? Should we return the key? No need to return the key, because key is the input through which you are searching for. You are finding the location where this particular key has been stored. So it's mean that you are required to pass on the subscript, return the subscript, the location where you have found that. Okay. So this is the definition. I've just picked up this, and this is the array. This is the key, that is the element that you are searching for. And remember, if you are passing an array to a function, याद है आपको, that you just pass on the name of the array is picked up, so the size is lost. So what do? With the array, we pass the size of the array also to the calling function. Okay, क्योंकि address, starting address तो आपके पास होता है, and the size you are also required to pass on to the structure. Then we use this for loop structure. Using this for loop structure, we can keep on comparing the key with each and every element, and if you find it, if the required key is suppose found at jth position, where j start from 0 to the last element, so you will return j. But if this loop ends, what does it mean? That you have searched it from 0 position to the n-1 position of the array element, and you have not found it. So in that case, you can return -1, or you may return something else, as I will demonstrate to you that you can have your own requirement, and according to that you can return the value that should demonstrate that the required or the desired key has not been found in the given array. ये तो है linear search. Now next is sorting. Do you remember, I have touched this topic also, and with an example tried to explain it, but today I will repeating that. I will be repeating this example of with an example and with some very good animated slides to demonstrate you the concept of the sorting. Sorting, जैसे मैंने आपको बताया, to arrange the data elements in ascending or in descending order. Ascending order क्या है? The smallest first, then the larger, then the next highest, then the next highest, and finally the largest value is placed at the last. Descending क्या है? Descend कर रहा है, means the largest element present in the data should take the first place, then the smallest one, then the smallest one, then the smaller, and the smallest should take the last position. इसको कहते हैं descending order. So as I said that this is very important, and some of the organizations may require, or even I'll be teaching you just after this particular example another technique of searching where we require that the data should be sorted. So what do we do in bubble sort? Suppose we have an array of n elements, so we keep on comparing the first element in the second if they are not in order. Order किसे कहते हैं? मैंने आपको बताया ascending or descending. So if our purpose is to arrange it in the ascending order, then we see that if the first element is larger than the second element, then we interchange the two. Interchange को क्या कहते हैं? Swap. और हमने swapping को बड़ी डिटेल से डिस्कस किया है in our previous lecture. Then we compare the second element with the third element, then the third element with the fourth element, until n-1 element and the last element. So we can complete one complete pass. What do we achieve in one complete pass? After completing one complete pass, we can find out the largest element, and that should place at the final position, the last position. The largest element should bubble up to the final position. पूरा एक पास हमने complete किया, and after completing the whole pass, what do we achieve? Just one element, and that is the largest element according to our desire has been found and placed it on the last position. इसका क्या मतलब हुआ कि if there are n elements, then we need to perform n-1 times this particular procedure, repeat again and again. So in the second pass we perform the same thing, but this time instead of going up to n, we'll stop up to n-1, and we will compare n-2 with n-1. If they are not in order, we will put them in order. So in the second pass, after completing the second pass, we have the two keys which are in their final position. In the third pass, we have the three keys which are at their final position, and in the ith pass we have I number of keys which are at its final position, and then we can just keep on moving, and in n-2 pass there will be two keys, n-1, the first and second, that you can place it into their particular order. There are certain improvements that can also be performed, but that I will explain you after giving this particular demonstration. So let us start. Suppose this is the elements, key elements 9, 6, 2, 12, 11, 9, 3, 7. We are required to sort these key elements into the ascending order. Means the smallest element should be at extreme left and the largest element should be at extreme right. So you know, मैंने आपको बताया था कि we'll compare first two elements 9 with 6. If they are in order, no, they are not in order. According to our desire, it should be in ascending order, or ascending order में 6 should be first and 9 should be second. So what do? We interchange 6 and 9. 6 and 9 are interchanged, and 6 takes this position and 9 takes this position. And now the next pair of numbers are compared. Again 9 and 2 are compared. Are they in order? No, they are not in order, because 9 is greater than 2. So they will be swapped, and now 9 comes up, bubbles up to the next position. Then compare 9 with 12. Since 9 and 12 are in order, so 9 will not bubble up further, rather the 12 will be taking the position of 9. Now if they are in order, we don't need to swap these two, and now this time we compare 12 with 11. When we compare 12 with 11, they are not in order. So what we do? We need to swap it. 11 should come up here and 12 should come up here. So 11 is here, 12 is here. Now we compare 12 with 9, they are not in order. Then 12 with 3, they are not in order. Then 12 with 3 and then 12 with 7, they are not in order. So what do we have achieved? We have completed one pass, and in this pass we have seen that all the elements are in, and or not all the elements, but the largest element has occupied and has bubbled up to the final position. So this is the end of the first pass, in which one key element has occupied its final position. Now we repeat the process. 6 with 2, they are not in order, so we interchange 2. 6 with 9, they are in order, no need to change. 9 with 11, no need to change. 11 with 9, are they in order? No, they are not in order, so we need to interchange the 2. 11 with 3, they are not in order. 11 with 7, they are not in order. So the pass is completed. Why we have not compared 11 with 12? Because we have already in the previous pass has realized that 12 is the largest value. So this time we will require to compute or carry out the comparison up to 1 less than the total number of elements. So in every pass you reduce the number of comparison to 1. So in pass number 1 you compare it up to n-1 times, क्योंकि जब आप n-1 पे होंगे तो nth position के ऊपर आप element को comparison को कर सकते हैं. So in the first pass it is n-1 is less comparison, second pass 2 less comparison, third pass 3 less comparison. So notice that this time we do not have to compare the last two numbers, as we know that 12 is in its final position. This pass therefore only requires 6 comparison. So there are 3 and 3 is 6 and 8. First time we have made 7 comparison, this time we made 6 comparison. Okay, then pass number 3. Compare 2 with 6, they are in order. 6 and 9, they are in order. 9 and 9, they are in order. 9 and 3, no, they are not in order. Swap the 2, they are not in order. 7 and 9, swap. 9 and 11, okay. So this time 11 and 12 are there in final position, so we have not compared it with that. Next pass, fourth pass, again 2 and 6, not, they are in order, but they are not in order. So 3 will take the position. 9 and 7, they are not in order. So this is the fourth pass. Okay. Next, 2 and 6, okay. 6 and 3 not in order. Swap the 2, they are in order. So no comparison, and this list is now sorted, but the algorithm does not know, because algorithm does not know whether these 1, 2, 3, 4 elements are in order. So how can the algorithm find out that it should stop? It will continue, but we can put a trick here that if and during any particular pass no swapping takes place, then you can come out of the no swapping takes place means every element is in their order. अगर एक भी out of order position होगी तो swap will take place. Swap means interchange of position will take place. So that improvement we can do that in the code, and that I will be explaining you when I will explain the code, that where you should place this particular check in your code to avoid the remaining number of passes. So compare 2 with 3, 3 with 6, and then this pass no exchange made, so the algorithm knows that the list is sorted. It can therefore save time but not doing the last pass. So there are 8 elements, so logically we should have 7 passes, but since the no swap takes place, so then this algorithm should be intelligent that if no swapping has taken place, it's mean that the data is in order. जैसा कि इस particular example में, इस particular pass के अंदर आपने देखा कि no swap has taken place in this because all the elements are in order. So dear students, I expect from you that now you must have understood the concept of the bubble sort, and now you should be able to write down the code or understand the code very well. Last time हमने इसको जब explain किया था first time, तो it was just the explanation without the demonstration. So I thought that I should be demonstrating more practically. So for that purpose I found this particular example on the net, and I decided to use it to explain you further how this bubble sort performs the functions to sort all the data elements in particular array. Okay, आगे चलिए. Before I start next topic, let's with this particular example that I picked up from the net. Just after this I found some very good 3-4 very good beautiful questions, so I decided to share it with you. So it says that which number is definitely in the correct position at the end of the first pass. याद है मैंने आपको बताया था कौन सा? Yes, the last one. The last number must be the largest. If we are doing sorting in ascending order, if you are doing in descending order, even then the smallest element that will be at the last position. ठीक है. The last number must be the smallest if we are doing it descending order, sorting in descending order. But since we have picked up the example and we say that we are doing it for in the ascending order, then the largest element should be at the position, last position. Next question. How does the number of comparisons required change as the pass number increases? Remember, ये मैंने आपको बताया था कि जैसे जैसे हम आगे बढ़ते चले जाएंगे, in every pass one less than the previous pass comparison आपको करने पड़ेंगे. ऐसे ही है ना? So let's see the answer. Each pass requires one fewer comparison than the last. How does the algorithm knows when the list is sorted? हमने इसके बारे में भी बात की थी. क्या बात की थी कि if during a particular pass, if no swapping takes place, no interchange takes place, it means that the algorithm should realize that all the data elements are sorted. When a pass with no exchange occurs, no swaps occur. Final question. What is the maximum number of comparisons required for a list of 10 numbers? Obviously, मैंने आपको शुरू में बताया था कि n-1 can compare the data element with n, so the answer is 9 comparison in the first pass, then 8 in the second. You keep on reducing one until there are only 2 elements, so then you compare second with first. So it's mean if we sum up 9, 8, 7, 6, 5, so there will be 45 comparison in 9 passes. That is required to sort the complete data of the bubble sort. Okay, I hope you must have understood. Let us see the code of the bubble sort. Although I have already shared it with you, but since today we have revised the topic, so it's better that we can also revise and go through this particular code. This is a function of the bubble sort. This is the basically definition, not the prototype. And you remember, if you are doing it a definition, we don't need the semicolon here. So it's a bubble sort. Input is an array. The data that is provided to this particular function, and this is the size. That this particular array contains the size number of elements present in that input. Okay, int temp. Remember, when we talked about the swapping, we said that in order to swap the contents of the 2 containers, we need a third container, and otherwise we cannot interchange the contents of the 2 containers. So this is the temp location. Then this is the outer loop. Outer loop क्या है? वो the comparison that we perform and that we keep on performing in each and every pass should be in the inner loop. Outer loop should be for moving from top to bottom, means pass number 1, pass number 2, pass number 3, pass number 4, pass number 5. This should be the outer loop. And then within every pass, within every outer loop, you will compare the number of elements. ऐसे ही है ना? So we will be using this integer pass is equal to 1, pass is less than size, pass plus plus. This is should be the outer loop, and this is the inner loop where we compare the 2 elements together, and after comparing the 2 elements together, if they are not in order, we put them in order. Okay, so इस bubble sort में आपने 2 चीजें ही देखनी है. एक ये loop को कैसे आपने हैंडल करना है, आउटर लूप कैसे हैंडल करना है, इनर लूप कैसे हैंडल करना है. इफ यू रिमेंबर के आउटर लूप इज कंट्रोलिंग द पास एंड इनर लूप इज कंट्रोलिंग द कंपैरिजन, तो तीसरी चीज रह जाती है स्वैपिंग. These are just only 3 points through which you can optimize the algorithm. Okay, or you can write down the complete algorithm, not optimize, rather write down the complete algorithm. Okay, so we can say pass number 1. So pass less than size means when you will be at position n minus size minus 1, then you will be comparing to size minus 1 to the last element of the size. Okay, and pass plus plus, it should be minus 1 here instead of this one. But okay, if we are using pass, 9 passes here, as we said in the previous example, that this here for 10 number of keys there should be 9 comparison. Okay, so 1 less than the number of keys is the size of the passes, and then the comparison passes से भी 1 minus 1, क्योंकि passes is less than this one and this size minus 1. When we say less than size, it means size minus 1. और यहाँ पे size minus 1 less than mean size minus 2. Okay, जब size minus 1 होगा और less than होगा तो it will obviously size minus 2 होगा. Suppose the value of the size is 10, size minus 1 is 9, और j less than 9 means j is equal to 8. तो समझ में आ गया कि comparisons जो है we will be using here. यहाँ पे passes होंगे less than size. If size is 10, so passes will be 9. If size is 8, then the passes will be 7. Okay, then we compare two consecutive elements, a of j with a of j plus 1. If they are not in order, we swap the two. Temp में हम डालेंगे a of j, and then a of j is equal to a of j plus 1, and a of j plus 1 is equal to temp. ये देखें, ये जो color use किया है blue color, that shows कि since you are using plus 1 here, so we should use minus 1 here, so that we may not compare the element, last element outside of the array bond. हम bond से बाहर comparison ना करें, otherwise it will corrupt over complete data of the array. Okay, so we have gone through the code. Now we talked about that the algorithm should be intelligent enough to see whether it should continue or not. अभी तो हमने यहाँ पे we have put 2 loops, and that loops will ensure that you will complete the sorting process even if the data is sorted. How can we stop that? This is a question, and you need to answer this question. Try your best and try to answer how can we make this code intelligent so that whenever the data is sorted, it should stop that. I'll just guide you what you can do, and then you will correct this particular code by yourself, and I will show you in the demonstration session or some other session the answer. What you can do, this is the swapping area. In this particular loop, you put some flag somewhere and you check that if no swapping takes place. What does it mean? That if you do not go inside this particular area, then the means that no swapping is required. Okay, so it's mean that you can put some check, and that check will demonstrate, and that should be checked somewhere here, that whether you have gone in this particular area. If you have gone in this particular area, you need to go through the next pass, otherwise you can stop that. So this is the hint I have given you. With this hint, try to put that particular check in this code and try it on the environment and run your program to sort the keys. Okay, so with this I assume that we have understood the concept of sorting and using the algorithm of bubble sort. Okay, this is just the explanation, number of comparison, and okay, this is another improvement which says that instead of size minus 1, so you no need to go again and again and again to carry out the comparison. हमने कहा था कि if the 12 is at its position, then next time it should not compare 12, but here it will 12 again and again. So what we can do here, instead of size minus 1, we can put size minus pass. So if pass is 1, first time it will run size minus 1. If pass is 2, in the next iteration of the loop, it will be size minus 2. in the pass is 3, it will be size minus 3. So instead of size minus 1, we can use this check j is less than size minus pass. So that will ensure that it will, if pass is 1, it will go 4 times, 3 then 2 times, and 4 means 1 time. So that will automatically reduce the number of comparison within each and every pass. That is the second improvement that you can perform in this algorithm. Okay, students, we have completed the demonstration of the sorting, and we have learned the concept of the algorithms, we have learned its code, and we have learned the improvement that we can put in to make this algorithm more intelligent. Okay, next we have discussed a topic of the searching, and we have learned one algorithm which is a linear search. Linear search में हमने हर element को compare किया था with our desired key in order to find out its location, and we said that it is inefficient if the size of the array is very large or if the data is not present. So how can we improve this? For that purpose, there is another algorithm which is called a binary search. Binary search we can apply to a sorted list of arrays. We compare the middle key. If we find the desired record, we can stop. Otherwise, we can discard the 50% data of our key, 50% data of our structure. So I give you a very good example. Suppose you are trying to find out the spelling of a particular word in a dictionary. You are searching a word in a dictionary, or you are searching the meaning of certain word in a dictionary. What do? You open up the dictionary somewhere from the middle and compare the word with your desired word. If your desired word is less than that, you discard the lower part of the dictionary, and then you concentrate on the 50% part which is on the left side of the position. You concentrate on that. Once again, instead of going page by page, you just open up somewhere from the middle and compare that. If your desired word is greater, then you discard the lower part and you are concentrating with the middle part of the half part, and you search from that. So you keep on reducing the size, not page by page, but almost you are reducing it to the half. The same concept, if we apply to search a particular key value, we call it as a binary search. Binary का मतलब होता है 2. So what we do, we use the same concept, but we precisely reduce the size of the array to exactly half. We compare the desired data with the middle. If it is present over there, then fabiha means okay, we stop. But if it's not there, we can compare and say that our desired data is less than that particular value, then we discard the lower half of the array. How can we discard the lower part of the array? Because we have made a condition that the data must be sorted. Since we know in the beginning that the array contains a data which is sorted, suppose we are searching key number 76 and the middle key is 50, so we can easily discard 50% keys from 1 to 50, or all the keys having a value less than 50, because the data is sorted. तो मिडिल की अगर 50 है तो उससे अबव जितने ऊपर की साइड पर होंगे मस्ट बी लेस देन 50, सो वी कैन इजीली डिस्कार्ड दैट. और ये हम किस सूरत में कह सकते हैं? इफ एंड ओनली इफ द डेटा इज सॉर्टेड. सो दैट इज द बेसिकली प्राइम फर्स्ट कंडीशन दैट द डेटा मस्ट बी सॉर्टेड. सो देन वी कंपेयर एंड मैच. इफ द मैच इज फाउंड, we stop. Otherwise, if the key is less than the middle key, then repeat the search on first half of the array. Or if the key is greater than middle, then repeat the search on the last half of the array. So This is a very good algorithm, and at most n steps are required, where 2 to the power number of element, n is the 2 to the power number of elements. क्या मतलब हुआ इसका? इसका मतलब ये हुआ कि suppose if you have a 30 elements, then you are doing a binary search. You are, every time you are reducing it to the half. So 2 to the power n number that should be greater than equal to 30 will give you the number of passes. So here, if we assume that there are 30 elements, so 2 to the power 5 is basically 32. So we can say that 2 to the power 5 means that it will require only 5 passes. First time the size of the array will be 16. Next time the size of the array will be 8. Third time the size of the array will be 2, 8 के बाद 4. Then 4 times the size of the array will be 4. And I've just confused. I just repeat it again. If there are 30 elements, 32 elements, in the first comparison के बाद the size will be 16. Second comparison के बाद size will be 8. Third comparison के बाद size will be 4. Fourth comparison के बाद size will be 2. And fifth comparison के बाद size will be 1. So if the key is present in the fifth iteration or in the fifth pass, you should be able to reach to that particular element. Or if it is not present, then you can discard that. Obviously, after making just the 5 comparison, you can determine whether the required key is present in the structure or not. So this is very, very fast. So instead of going through 32 times comparison in the linear search and then you determine that the desired key is not present in this particular searching algorithm, only after 5th comparison either you will find it or you will say that the desired key is not present. So let us see this practical demonstration of this beautiful algorithm. This is binary search. Suppose this is the list of the data, and I've just picked up the same, once again I've picked up this particular example from the net to demonstrate you with the animated concept. So I've used here the local names so that you should be able to understand that. Just write dictionary. So we have got 10 people present in the array, and suppose I'm interested in searching Mr. Name. So this algorithm is for finding an item in a sorted list or determine that if it is not present in the list. So is Mr. Name is in the list? I need to find out with the help of algorithm that whether Mr. Name is present in the list or not. So according to this algorithm, what should I do? I'll first find the middle of the list, and I can find the middle of the list by taking the mean, by having upper bound 10, lower bound 1. 10 plus 1 divided by 2 is 5.5. So I can round it up to 6, or I can round it up to half. Whatever algorithm you apply, either you truncate, or then you truncate every time, or you don't truncate, you round off, then you round out every time. Okay, so I need to compare it with the 6th element, and the 6th element is compare name with Sarfraz. So we say that, what do we say? We say that Mr. Name and Mr. Sarfraz, name comes before Sarfraz, n is less than s. So what should we do? We should discard the remaining part of the list. Now the size of the list should remain half. So now our size of our list is, this time instead of 10, this time the size of the list is 5, and we have here 1, 2, 3, 4, 5. The same algorithm, find out the middle. That says 1 plus last, or last plus 1, which is 1 plus 5 divided by 2, which is equal to third element. We compare Naeem with Hamid. When we compare Naeem with Hamid, then it says that Naeem and Hamid, Naeem comes after Hamid. Why? जब आप n को h के साथ कंपेयर करेंगे तो name n is greater than h, so it's mean that name comes after Hamid. So what do we do now? we can discard this 50%, and this time we will have only this Mr. Naeem and Mr. Rashid. Out of this list it is reduced to half, and next time it is remaining only 2. यहाँ से 10 में से there were 5, and now after this comparison, after 5 they are 2. Okay, now we find out the middle, which is 4 plus 5 divided by 4, which is 4.5. It should be 5. So we compare it, Naeem with Rashid, and since Naeem comes before Rashid, so we will discard this lower part. There is no lower part, only Rashid. So now we are left with, here we are left with only one Naeem. We compare Naeem with Naeem, so found the record. So what happened? 10, 5, 2, 1 found. This is a very, very interesting and very good algorithm that we should be able to use this algorithm for the linear search. Let us see. Okay. The code of this algorithm I will be demonstrating you in the next lecture, and I have forgotten to include it into this particular next slide. So in the next lecture I will be demonstrating you all the examples that I have used in my lecture. So I will be sharing with you the code, and I will also be executing that code in the Visual C environment to explain it to you. So I leave it for you. You should be able to write down the code by yourself. Try to write down this code by yourself. आपको क्या करना है? सबसे पहले आपने array को read करना है, then उसके बाद array को sort करना है. Sorting के लिए you can use bubble sort. Once the data is sorted, then you can apply this beautiful demonstration which I have picked up from the net for you, and I assume that you have understood the concept, and try to write down this algorithm and then write down the code and then execute that. So I leave it for you as an exercise till the next lecture. Okay, so students, we have learned arrays application, and arrays application where we have learned linear search, we have learned sorting, and in the sorting we have learned bubble sort, and then we have learned the advanced version of searching, which is the binary search. So in all these three applications, you must have noticed that I have not touched the multi-dimension array. I have intentionally concentrated on the array which is a single dimension. But array is a data structure which is a multi-dimension. You can have a 2-dimension which is called table, 3-dimension, or you can have any number of dimensions, and there are certain restrictions, theoretical restrictions among the languages. So the remaining part of my lecture now I will be concentrating on the multi-subscripted array. What does it mean, multi-dimension array? So multi means more than one. So we start with a 2-dimension array. If we understand that 1-dimension array, if we understand 2-dimension array, then we should understand the multi-dimension array. So in the multi-dimension array means a 2-dimension array where we use 2 subscripts, and 2-dimension array is also called a table. In a table there is a concept of rows and columns. So we have a row, that is, these are the rows. This is called row number 0, and this is row number 1 and row number 2. And then we can have a multiple columns. So we can have a column here, column 0, column 1, column 2, and column 3. So the array is also called array of arrays. So what does it mean? It means that we can say that A of 0 is an array of 4 elements. A of 0 is an array of 4 elements that contains 0, 1, 2, and 3. So if we use this concept, A of 0 is the name of the array, and this array has 4 elements. In this way, that is another way of explaining the 2-dimension array. Or if we are using it as a table, then we can refer any particular element with the help of two subscript, where A of 0, 0 means the first element of the array. A of 0, 1 is the second element, third element, fourth element. Then row number 2, first element, second element. When we say first row, then it is 0 because we start from 0. When we say second row, it starts from 1 because we have started from 0. When we say third row, it starts from 2 because same logic, we are starting from 0. So this is the concept of the multi-dimension array. Now let us move further. We can refer each element just like we have been doing it in the past with the help, instead of one subscript, now we are using two subscript. So we can use this array anywhere. We can use it as part of the expression. We can use it in the output statement, which could be a printf or a cout, or we can just put it up in any expressions. But we need to put these two square brackets in the pairs. Each pair is representing one subscript or one dimension of the array, and two pairs is a two dimension of the array. If you put a comma here, it will generate a syntax error. Okay, so you are bound to use it like this. You are bound you cannot use it like this. Function prototype. You must specify the size of the subscript, but first subscript is not necessary as with the single subscripted array. याद है आपको, जब हम function में array को pass on करते हैं तो हम उसके subscript, it passes on the complete array and we just need to pass on the size of the array. Here, if we are using a two-dimension array, then what you need to do here, the first one is not necessary, but you are required to pass on the size here as the second. Okay, that is the concept through which you can pass on a two-dimension array to any particular function. Let us see. We have learned how to initialize a one-dimension array. We have done that with the help of some initialization techniques. Then we have done that with the help of loops, and same we can do it with the two-dimension array. So in this particular example, this is a print array. Basically we have a function prototype here, and here we have initialized. So int array 2, 3, it's a 2 rows and 3 columns. This is row number 1, this is row number 2. Row number 1 contains 3 columns, row number 2 contains 3 columns. Do you remember that you may skip some elements? Similarly, you can do that by putting it, you can remove the two parentheses here, and you can simply put all the 6 elements in one. That will automatically split up into 2. Okay, or as we have done it here, 1, 2, 3, 4, 5, we have skipped 6. This is 5 elements instead of 6 elements. So what has happened? क्या होता था single dimension array में? जो remaining part of the elements are initialized, वो garbage में? No, they were initialized to a 0 value. Same goes here. जो element यहाँ पे आप skip कर रहे हैं, all the remaining element will be 0. Similarly, in the third, what should happen? 1 and 2 is there, the third element should be equal to 0. Then second row, अब आप 1, 2, 4 इकट्ठा नहीं लेंगे क्योंकि you have specified in the form of the curly brackets. That shows row number 1, that shows row number 2. So row number 1 contains 1, 2, 0. Row number 2 में क्या होगा? 4, 0, 0. So in the way it should be initialized. We will see the output also. So we can just send this message and we can print array 1, then we can print array 2, then we can print array 3. Okay, so note that note the format of the prototype. ये मैंने आपको बताया कि you have to be very careful and you need to provide the size, and this size should be here in the prototype. ठीक है, याद रहेगा? Good. वेरियस इनिशियलाइजेशन ये मैंने आपको ऑलरेडी एक्सप्लेन कर दी है, एंड आई अज्यूम दैट यू हैव अंडरस्टूड दैट. नाउ हाउ कैन वी प्रिंट? We have called a print function. We can print by picking up each and every element of the array. आपको याद होगा लेक्चर के शुरू में मैंने आपको एक ऑपरेशन बताया था that can be performed on array, और वो ऑपरेशन था traversing. Traversing की मैंने आपको डेफिनेशन क्या बताई थी in the beginning? To access each element of the structure exactly once. Now, in this print of an two-dimension array, what we are doing? We are printing each and every element of the structure two-dimension array exactly once. So basically this printing process is achieved by traversing, by accessing each element of the structure exactly once. And how we can do that? For that purpose, since it's a two-dimension array, we need to put 2 for loops. For a 3-dimension array, we need to put 3 for loops, and for a 4-dimension array, we need to put 4 for loops. Okay, so simple, इसको simple रखते हैं. For row is equal to 0, row less than 2, row plus plus. For column is equal to 0, column is less than 3, column plus plus. And in this way, for row 0, there will be column number 0, column number 1, column number 2. Okay, 0, 1, 2. For row number 1, it will be column number 0, column number 2, column number 3. For row number 2, no, 2 नहीं होगा, less than 2 है, so it will be 0 and 1. There will be 2 rows. Column कौन से होंगे? Column होंगे जनाब less than 3 का मतलब है 0, 1, 2. So it's a 2 row 3 column, and with the help of this less than 2 and less than 3, we should be able to access each element of the array, and we should be able to print each element of that particular array. Okay, this is the output. Let's go back again. मैंने आपको बताया था it should be 1 2 3 4 5 6. It should be 1 2 3 and 4 5 0. ये क्या बताया था? 1 2 0 and 4 0 0. क्या आउटपुट आई? 1 2 3 4 5 6, the first one. 1 2 3 4 5, the last element has been initialized to 0. Then 1 2, देखें 1 2 4 नहीं है, because we have closed in curly brackets 1 and 2. So the third element was not touched, so it's automatically initialized to 0. Then we only provided one element, which was 4. The remaining 2 elements have been initialized to 0. Okay. Okay, let us take another concept. 2-dimension array or 3-dimension array. Usually a 2-dimension array may have 2 columns, may have 3 columns, may have 4 columns. If we restrict ourselves while accessing the array, if we restrict ourselves to one row, that is, we pick up row number 0 and access all the elements, and we may correlate all the elements together, we can call this array as a parallel array. क्या मतलब है? We, in this particular example, let us see that this particular row represents a student and column represents the exam. So if we are talking about student number 0, we should restrict ourselves to only 0 and 1, 0 and 2, or if there are maybe more exams, then 0 and 3, 0 and 4, 0 and 5. So the first subscript should represent the student number, and the second subscript you can just keep on varying from 0 to n, and that may represent the corresponding data to that row, particular row. और अगर हम इस पर्टिकुलर एग्जाम्पल में रो को अज्यूम कर रहे हैं, रोज आर दी स्टूडेंट्स एंड द कॉलम्स आर देयर एग्जाम्स. सो देयर इज अ वेरी स्मॉल प्रोजेक्ट, एंड इन दिस प्रोजेक्ट वी वुड लाइक टू ट्रैक द स्टूडेंट ग्रेड्स. वी विल इनिशियलाइज द स्टूडेंट डेटा, मीन्स कि हम कीबोर्ड से नहीं करेंगे अपनी आसानी के लिए. वी विल बी यूजिंग द डेटा थ्रू इनिशियलाइज्ड इनपुट, एंड देन वी विल कीप ट्रैक ऑफ द स्टूडेंट ग्रेड्स. Or we'll be using a 2-dimension array as a table. Rows are the students, columns are the grades. Now we are required to prepare the functions to find out the minimum grade of the students among all the grades, to find out the maximum grade of any particular students among all the grades, कौन सा student है किसने top किया है, कौन सा students है जो which has flunked and is at the bottom position. We may require to find out the average, maybe for each student or maybe for all students, and we would also like to develop a function to print out the results. तो ये सारे achievements करनी है in the next example. So today I will just be concentrating and explaining this example, and in the next lecture I will be showing you execute it in the environment. So let us discuss one by one, tracking the student's grade, and this particular just forget about it for the time being. I will show you in the last lecture when I use set width in C in and C out. So I said that this is the IO stream, and when I will be teaching IO stream, then I will show you that why we need this IO manipulation. Okay, so if maybe since I have again picked up this example from the net, so therefore I have not made any change in this particular input that I have received from there. So the students, suppose there are 3 students and suppose there are 4 exams. So each student is required to undertake 4 exams. Then we have a prototype of a function. This function minimum finds out the minimum grade of the student. This maximum function finds out the student which has the maximum grade. Double average function computes the average of the grade that each student has achieved. Print array provides us the display result of each and every student. यही 4 बातें कही थी ना, यहाँ पर हमने मिनिमम निकालना है, मैक्सिमम निकालना है, एवरेज कैलकुलेट करनी है एंड प्रिंट आउट. सो these are the 4 function which we are doing it. हमसे कहा गया था in the use initialized data, so we have used this initialized data. So it's a 2-dimension array. Initialize the student grades. So student grade is the name of the array. First row representing the student and column representing the exam. So student 0 has got 77, 68, 86 and 73 marks. Student 2 got 96, 87, 89 and 78 marks. Student 3 got 70, 90, 86 and 81. Seems to be good students. Okay, output array. First of all, we like to show this complete data on the screen. So for that purpose, we can call a function print array. Then determine the smallest and largest grade student. So we can set here C out lowest grade, and then we can compute. Okay, we have passed on this array students grade. We have passed the name of the array. And now we are passing out here the students and exams. So we may not be using the concept that I have said that at the time of the calling of the array you may require to pass it on that. But here we see that we are in a particular example we are passing the name of the array and we are passing both the students and the exam. We can pass on and we can just then use that. Similarly, we can find out the highest grade student here. Calculate the average. So we calculate the average. Each person is a student until the person is less than the total number of students, persons plus. The average grade of the first person is, we call the function here, and here since we are passing out only that particular row, so in that particular row we are passing out the student of a person. So basically we 2-dimension array ko we are passing out only the 1-dimension array which is showing a particular row. So we are sending the data of one row to this average function, and average function jo hai, that means this is the dimension, okay, that we need to pass on separate. That this is student 0, that should contain the column 0, column 1, column 2, column 3, and it should here exams mean it should have. So this is the definition of the minimum. the definition of the minimum initialized to highest value, we assume that in order to find out the minimum, when we define minimum, we define the largest value. Otherwise, अगर आपने कहा कि minimum is 0, तो 0 से तो नीचे कोई जाएगा नहीं, so you will have a wrong result. So when we initialize the minimum value, we try to initialize with the maximum value. So 100 से ज़्यादा किसी के marks नहीं हो सकते, तो we assume that O grade is equal to 100, and then we find out. Now we are required to traverse the two-dimension array to find out that which student, because you have to find out the minimum of the grade. So you will find out row and column. This is the students and this is the test, and say I comma j is less than low grade. Whatever the first one will occupy this position, and whenever you will find the lowest grade, then this will be the lowest grade, and you can find out that this is the lowest grade. The function will return that this is the lowest grade. Similarly, we can find out in the reverse, we can find out the maximum grade. Initialize the lowest possible value. अब maximum में देखें, we have initialized it with 0. Low को हमने initialize किया था 100 पे, so that के whichever will be the next value should automatically be picked up. अब highest value को हमने 0 किया, so that whichever the real first value, that should be the actual value. Once again, we are traversing the data and finding out which is the highest grade achieved by the student. This is computing the average of each student. देखिए हमने इसको pass on कर रहे हैं with the help of this array, and say that there are 4 tests. Less than test, and we are calculating the cumulative sum, and then we divide the cumulative sum with the number of tests. That should give the average of one particular student. So we can we can say that return static cost double sum divided by this as an average. So हम हर स्टूडेंट की एवरेज जो है वो रिटर्न कर रहे हैं, और जो कॉलिंग फंक्शन है वो 1 by 1 हर स्टूडेंट्स के लिए उसकी एवरेज के लिए इसको कॉल करेगा. प्रिंट अरे, once again you need our array, or this is the whole data, students grades, then exams. This is the definition of the function. So 0, 1, 2, 3, this is just a title, and here we are using two-dimension row, means 2 for loops. So this is for the students and this is for each grade. These are just the headings that it should print on the screen. So I hope you have grabbed this concept. Let's see what should be the output. The array is, this is just a heading, and student 0 has got this array. This is the input that we have displayed with the help of this one. Then the largest grade is 60, lowest grade is 68, and the largest grade is 96. Then the average of the student 0 is 76, average of student 1 is this one, and average student 2 is this one. So ये हमने कहाँ पे देखा था? ये this is the main program here. This is the program. Prototype, this is main, this is printing the result, and here we are calling the the lowest grade, here we are calling the highest grade, here we are computing the average. So basically this output here, this output here is by the main function. Okay, so students, we have seen now an application of a two-dimension array, or we can say that a multi-dimension array, and we have gone through a very simple project through which we have traversed and we have carried out certain calculation on certain rows. Rows की calculation हमने किस तरह की कि हर students की हमने average compute की. Rows and columns को कैसे किया? We have found out the lowest grade and we have found out the highest grade. So we have done the traversing. We have going through each and every record of the two-dimension array by going through it through rows and going through it through columns. Okay, so with this we have concluded today's lecture, and in the next lecture I will be giving you some hands-on demonstration in Visual C environment, and whatever I have taught you in the last few lectures I will try to demonstrate most of the examples that I have used in my lectures, that how these example will execute in C environment. Okay, till then, Khuda Hafiz.